We continue the ideas for our trusses. We have our fourth truss. In ideas of trusses, we just give hints for solutions and final answers. I recommend that you stop the video, go on with your calculations, and rewind your video to make sure that you proceeded correctly. And if you have any questions, please don't hesitate to convey them and they will be answered. We have this truss from symmetry. We can conclude that reactions at YA and YB are equal, each 12 tons. We consider section S1 S1 because we need thoroughly the value of AD. Let us discuss the value of AD and think it over. What about taking equilibrium at joint D? Considering joint D, equilibrium in the x direction will give that AD equals DB, but no values. And considering equilibrium in the y direction for joint D will give another unknown, which is DC, and therefore we couldn't start with this joint. We need section S1 S1, and let's think it over. This section passes by 3 or cuts 3 members, HC, FC, and AD. We need an equation that makes us get rid of 2 unknowns to keep us with 1 unknown in one equation. Therefore, we consider moments about C to cancel HC and FC and obtain the value of the internal force in AD. And we point out that angle theta here has a tan of 0.5. Here we are. This is the value of force in AD. Now we can consider joint D, and sigma forces in the y direction gives DC. We proceed with joint C here. Of course, if you consider joint C and equilibrium in the x direction, we will get no conclusions because we have more than one unknown. But if you consider equilibrium in the y direction, we can inspect from symmetry that HC equals the second inclined member here, and we already computed DC, so we will be left with one unknown HC, and by computations it will be 0. Considering section S1 S1 again and equilibrium in the y direction, we can get that HC equals 0, the same conclusion we obtained from considering joint C. See, you have more than one attack for the same member. You choose whatever you are convenient with. For joint H, we already have HC. So, the unknowns here connected to joint H are HG and HF. It is a wise start to consider equilibrium in the x direction to get GH and the y direction to get HF. We already have HC. So start with whichever direction x or y you are convenient with. Here is HF and HG. We can proceed with joint E here. We have the unknowns EG and EA. If you consider equilibrium in the x, you will have 2 unknowns. So start with equilibrium in the y direction to get EG, and then having EG, you can now consider the x direction to get EA. Joint F. We we already have HF calculated from joint H, and we have GF, FA, and FC connected to joint F. So, considering the Y direction, the only forces that will appear are the known HF and the required FG. So we get that FG equals 4.24 tons tension. For joint G, we know that we already computed GE from joint E, GF from joint F, and in the Y direction we are only left with AG unknown. So considering the Y direction, we can get this unknown. GH in the X direction is previously computed from joint H. We can have a check, any check you are convenient with. Let us consider joint A and sigma forces in the Y direction. You take joint A, you have a 12-ton YA, the vertical member AG, and the inclined member AD. Of course, the component of the inclined member AD in the vertical direction. Just make sure that the sum of all the forces together has the value 0. This concludes with our course.